Hello everyone, this is DSA Zindabad. Today we are going to solve the fourth question of Arsh DSA sheet, and the question is set matrix zeros. Now let's look at the problem statement. Given an m cross n integer matrix, if an element is zero, set its entire row and column to zeros. You must do it in place, right? Now let's look at the example. What does this example says? We are given this input matrix, which is 1 1 1 and 1 0 1 1 1 1, right? Whenever we found a zero, we need to set its entire row as well as its entire column to zero so that the resultant matrix will look something like this, right? Now let's look at the second example. Let's say we found this zero, so we need to set this entire column as well as this entire row to zero, right? 0 0, right? When we found this zero, we need to set entire row as well as entire column to zero so that our resultant matrix looks something like this, right? So what is our main goal? To convert our resultant matrix to something like this, right? Now let's jump into the approach. First of all, let's discuss the brute force approach, right? Brute force approach. Whenever we see a matrix question, what comes in our mind? Like some sort of traversing, right? Same thing we are going to do this in this problem, right? We just need to traverse the entire matrix and follow some condition, and the resultant matrix will be our answer, right? Now, how we are going to traverse over the matrix? This is our main question. Now, let's take this example, example 2, right? This example, right? Now, we'll be taking another 2D matrix of same size, which is 3 cross 4 over there, right? Now, what we are going to do, we'll just iterate over this complete matrix through each and every element one by one. If we found that the element is zero, let me just copy this thing over there. So now we have this matrix, right? Now, whenever we find an element zero, we'll just simply copy this element to this extra matrix which we take initially. This is 2D matrix. Right? We'll just simply copy zero over there in the matrix, right? Now we'll check whether its entire row contain the element zero or its entire column contain an element zero or not. Now, as we can see, like this contain zero, right? So this will be equal to zero. Now moving on to one, we'll check. We'll moving on to one, we'll again check whether its entire row have zero or not. If its row contains zero, then we need to put this element as zero. Now moving on to two, as we can say, like its entire row contains zero, so it will ultimately become zero, and this zero will directly copy to this 2D matrix, right? Now when we move to three, for each and every element, we need to check whether its row or its column contain zero or not. If it contains zero, then we need to replace this element as zero in the 2D matrix, right? Now for three, as we can see, like its column contains zero. So this three will be replaced by zero, right? Now moving on to four, as we can see, its row as well as its column do not contain any zero. So this value will be as it is in the 2D matrix, right? Same goes for five. And in this way, we'll just fill the 2D matrix. Now at the end, what we are going to do, we'll just override this input array again with this temporary 2D matrix, which we take initially for storing all the elements according to the setting condition, right? Now let's discuss the time and space complexity for this problem. For this, time complexity will be something big of n cross m plus n plus m. Why this is so? This is for iterating over the matrix over our initial matrix, this input matrix, right? Iterating over the matrix. Now this n plus m, this is for a row, this is for a column. Now what we are doing in this approach, whenever we find an element, right? Whenever we find an element, we need to traverse over this entire row as well as its column. So it will require n and it will require m. So it will ultimately will become big O of n plus m. So the time complexity would be something like this: n cross m plus n plus m, n plus m, right? And the space we are using of the 2D matrix, since we are creating a 2D matrix, so space complexity would be big O of n cross m, right? I hope this brute force is clear to all of you guys. Now let's try to think about the better approach, right? Now what could be the better approach? Better approach, right? Now, in the previous approach, like in brute force approach, what we are doing, we are just traversing over the matrix, and for each and every element, we are just checking whether its entire or its entire column contains zero. If they contain zero, then we'll just directly put like override this element to be zero, right? So for each and every element, we are again traversing over the row, over the column again and again. This is the repetition which we are doing, right? Like, what do I mean? We are we require this much of extra time for traversing over the row and column again and again for each and every element, right? So let's try to reduce this time, right? Now, what we'll be doing, we'll just take this example again, right? This is our example. Now, what we'll be doing, we'll just create two arrays or two vectors to store whether the row contains zero or not, and the same goes for column, whether the column contains zero or not. If the column contains zero, then we'll just mark it as true, and if the row or the column don't contain the zero, then we'll mark this as -1 or false, right? Now what we'll be doing, we'll just check if zero is there, then we'll mark it as true. If zero is not there, then we'll mark it as false, right? Now we'll just iterate over the complete matrix. Now, as we can see, like this row contains zero. So let's mark this as true. Now this row don't contain any zero. So this will be marked as false. Now again, this row don't contain any zero. This will be marked as false. Now we need to check for each and every column also, right? Now this column contains zero, so this will be marked as true. Now this column don't contain any zeros, so this will be marked as false. This column also don't contain any zero, this will be marked as false. This column contains zero, so this will be marked as true, right? So we just decrease the time, which is like iterating over each and every over each and every row and column for. Now with the help of these two arrays or two vector, what we are doing, we are just reducing the time complexity to just big O n cross m, right? And the space complexity will also be reduced, which boils down to big O n plus m, right? Now let's do a dry run, like how this approach works further. Now, whenever we find like we'll just iterate over these two arrays and check whether there is true. Then if we found like if there is true, then we'll put uh, the element as zero. If we found that true false, then again 0. If false true, then again 0. When we find false false, then it will be marked as it is. No 0. No 0 over there. Now, what do I mean by this? Now let's take this example again, right? This will be true, false, false, and this will be true, right? And this will be something like this: true, false, false. Now we'll just iterate over the complete matrix again. Now when we find, like, when we are over at this 0, we'll check whether it's we'll look for these two arrays. This is for column and this is for row, right? Now we'll check this is true, this is true. When there is true, then it will be 0. So this will be marked as 0. Now when we move to false, true, this will also be marked as 0. False, true, this will also be marked as 0. This is already 0, right? Now we'll just move to the second row over there. Now, as we can see, this has true value and this has false value. So this will be marked as 0. Now this has false value and this is also false value. So the element will remain as it is. Now same goes for 4. Now when we move to 2, as we can see, there is this like true and false over there. So it will be marked as 0. Same goes for this one and same goes for this one. And for 3 and 1, the element will remain as it is. I hope this approach is clear to all of you guys, like why we are using two extra array or vector for this. So that we don't need to iterate over the column or the row again and again for each and every element, right? So ultimately, the time complexity would become big of n cross m for just iterating over our matrix, and space complexity would ultimately boil down to big of n plus m. Why big of n plus m? Because we are creating two vectors or two arrays, right? To identify the state of the element, we are just creating this two vectors, right? Can we further optimize this approach? Now let's try to think, right? Now, now let's take this example, right? Now in this, we'll try to reduce the space complexity to big of one, right? Since in the question it is mentioned like we need to do it in place. Right. So what we'll be doing, we'll just use the first row and the first column to be the temporary row and temporary column, as we did in this previous approach, like this sort of thing. We'll use the first column, first row for this, and first column for this, so that we can decrease the space complexity, right? So with the help of, now we'll just iterate over this matrix, which will be left, right? Now we are going to check whether this contains this matrix, like this is of size, I guess, 2 cross 3, right? Now we'll just look at this matrix and we'll just fill all the values in the first row and the first column, right? And this first row and first column will be used, first row and first column, right? Now we'll just look at this matrix, which is there of size 2 cross 3. Now when we move to this element 4, now we'll check whether this contain 0 or no. Now since it do not contain any 0, so this will remain as it is, right? Now again, we'll move to 5, same thing. Now we'll move to 2, this will remain as it is. Now moving on to 3, this will remain as it is. Moving on to 1, this will remain as it is. And moving on to 5, this will remain as it is. Now, since this example already have like first row and first column as it is, So let's try to take some different example for this, right? So that this approach is clear to all of you guys, right? Let me just take this example. Now, what we'll be doing, we'll just use the first row and the first column, right? Now, what we'll do, we'll treat this inner matrix as our input matrix, Now we'll do the same thing as we did in the better approach, right? So this will be like sort of temporary row and temporary column, right? So what we'll be doing, first of all, we'll iterate over this array, over this input matrix, which we are going to consider, right? Now, iterating over this row, as we can see, like there is 0 over there. So will this 3 will ultimately become 0. Now again, moving on to the second row, as we can see, like there is no 0 over there, so it will remain as it is. Now moving on to the last row, there is no 0 over there, so it will remain as it is. Now we'll traverse by column also. Now, as you can see, like there is no 0 over there and there is 0 over there, so it will ultimately become 0 now. So these are the temporary row and column, right? Temporary column. What do I mean by temporary row and column over there? Same thing as we did in this approach, like this sort of thing. Now, after this, what we are going to do, we'll just iterate over our complete array itself so that we can mark all the element as according to our condition. Like whenever we find like there is 0, 0, then it will be some remain 0, 0, some other element, then again 0, element or 0, then again 0. When we find element, comma element, then it will remain as it is, right? These 4 conditions we need to follow, right? As we did in the better solution, this thing, like this thing, true, true, and false, false, right? Now let's try to do the further diagram, right? Now, after this, we'll just iterate over the complete matrix, right? Now, first of all, we'll check for the 4 uh, whether its entire row or its entire column contain any 0 or not. Yeah, as we can see, this contains 0, so this will become also 0, right? Now moving on to this 0, this is already 0, so there is no need, right? Moving on to 2, as we can see, its column as well as its row contains 0, so this will also become 0, right? Now moving on to this 3, as we can see, it contains 1 and 1, which is element, so it will remain as it is, right? So this will ultimately become, sorry, 3. And moving on to 1, as we can see 0 over there in the temporary row. So this will become 0, right? Moving on to this 5, this also contains 0. So this will also become 0. Moving on to 7, its row or column do not contain any 0. So it will remain as it is. Now moving on to 6, its column contains 0. So this will also become 0. And this will also become 0. Right? Now write this matrix as it is. 1, 0, 0. So this is our first step, right? But our ultimate answer would be something like this. Now, second thing, after this step, what we need to check? We need to check if our first row contains any 0 or not. First row contains any 0 or not. And same goes for column. Column also. Column also, right? Now, as we can see, like this row contains 0. So this will also become 0. So our ultimate matrix will look something like this: 0, 0, 0, 0. And this entire column will also become 0, right? 0, 0, 0, 0, and 0, 3, 0, 0, and 0, 7, 0, 0. Why we are doing this thing at the end of the, like after the first step? Because we also need to check the same thing for our row, for our first row as well as our first column, right? Because we initially assume like our first row and our first column will be the, like some this will be used to determine whether our input array contains 0 or not, like same thing as we did in the beta solution, like the true and false kind of thing, right? So at the end of the problem, like we are going to take the entire matrix. We cannot leave the first row and first column. So we need to again check for the first row as well as first column. This is the reason why we are doing this, right? I hope this approach is clear to all of you guys. Now let's try to code this thing up. Initially, we'll be having bool x equal to false, false, and y also equal to false. Why? This is for our first row and first column. First row and first column. Now in temp will store the row and in temp will store the column. Matrix 0 over there. Right. Now we'll just iterate over a complete matrix, right? Over a complete matrix. This first iteration is for storing the values at the first row and the first column, right? Now what we'll be doing, if we find matrix of I comma j as equal to 0, then what we are going to do, we'll just set matrix of I comma 0 as 0 and matrix of 0 j equal to 0, right? And there is one more condition. If we find like, if we are at the initial like we are at the first row, then we need to change x to true, and if we are at the first column, then we need to change the value of y, right? Now after this, what we are going to do, we'll just consider this amount of matrix, the insider matrix, leaving behind the first row and the first column, right? We'll just iterate I will be equal to 1 less than m I plus plus. Same goes for column, and column will start from 1. Now at this point of time, we'll check if matrix of I zero is equal to 0, or matrix of 0 j is equal to 0. This kind of like true or false things, right? Then if this condition holds true, then we need to change this element to 0, right? Now at this point of time, like we are done with our first step. Now as we discussed in the diagram of the optimized approach, now we need to look at our first row as well as first column, right? So we need to do the same thing for our column as well. I less than m I plus plus, matrix of I of 0 will be equal to 0, right? If this condition holds true, like if we are at the first column, right? Now when we find any element to be equal to 0 at the first row, then we need to do the same thing. J less than n, j plus plus, and matrix of 0, j will be equal to 0. Right? Now let's try to submit this thing up. Now this runs perfectly fine. Now let's try to submit. So this code runs perfectly fine. Now let's discuss the time and space complexity for this problem. Since we are just iterating over this complete matrix, so this will require big of m cross n time, and this will also require big of n cross m, and this will require big of m, and this will also require big of n. Ultimately, our time complexity would become big of n cross m, right? And space complexity will be big of 1, since we are not using any extra space, right? I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please like, share, and subscribe, and comment if you have any doubt. Thank you so much.